Hello everyone, it's Sean and welcome back to Having Fun Repairs. You're probably interested in why I brought this Playtech puppy that we worked on in the past back onto the bench. And to be honest, it's kind of a rather boring video in my opinion. Minus a quick discussion on infrared signals. But I really didn't do much other than gut the board out of this thing and then hook the motor directly up to the batteries. That way, as soon as you turn it on, the wheels are constantly running, which is, not good for longevity, at least concerning the batteries, because we're not going to have the very best lifespan. And there's no control over this. The toy previously operated off of a remote of some sort that transmitted an infrared signal to cause the device to go forward or backwards, I believe. It might have just have been forward for this one. But anyways, I kind of want to try and remedy that and see if we can find a way to get this back underneath controller type control, or remote type control, if I can put it that way. Anyways, let's dig into this. You'll see what I'm talking about. Fairly simple teardown, nothing you haven't seen before. Essentially going to take the batteries out and cut the zip tie that's holding the body of the toy to the actual clamshell that houses all the electronics, or what would have had electronics if I hadn't cut them out in a different video. But nothing too special here. I guess now is a good time as any just to say that if you're new to this channel and you enjoy the content that you're viewing, then by all means please subscribe. That helps grow out my channel organically, and so does giving the video a like. I also enjoy comments in the comment section, get quite a bit of constructive feedback, and I take all those things for what they are, and I do appreciate it. I do happen to operate Having Fun Repairs as a business here in the state of Oklahoma, but if you want to know more about the business side of things, you can go to my Google site. The link is in the description. It will take you to the business tab. Willing to accept any type of repairs. I can pretty much work on anything, although I specialize on radios, but if it's broke and you want it repaired, don't throw it away, even if it's something as simple as like this toy right here, or say you have a car amp or stereo or a radio or a laptop or a cell phone, willing to take it on. You can read more about that on the Google site. And then if you just want to donate, then by all means, PayPal's in the description too. Trying to remember all the little bits of components in this thing. Oh yeah, the wheel. I'm going to have to put that somewhere safe. That little metal bar that goes in the center is likely to get lost if I'm not careful. So, trying to familiarize myself with how everything was hooked up, mostly just to ensure how the wires go between the positive terminal of the motor and the negative terminal, if you can really call it that, because it's a DC motor, so you just swap the leads and you reverse bias essentially the motor, and it can spin in either direction, but at least something for me to annotate later. And here's what I'm really after. My son has a broken RC that is remote controlled. What is this, a Lamborghini or something? And the suspension on the front is broken, and I honestly don't have a 3D printer or any way to repair that. However, the components inside the car are going to come in handy. Now, the original Playtech dog operated off of infrared transmitter receiver in order to operate, to go forward and backwards. But this car is going to operate off of RF instead of IR. It's going to send a signal out over the airways in the megahertz range for communicating, but I think we could probably take everything out of this and use some Duraleak batteries there. Man, yeah, Duracell is not really the name brand I would go with, but that's what I had in that vehicle. But yeah, I think we can probably move over some of the components inside this toy RC car into the dog to restore functionality again. At least that's my thoughts for now, and I'm hoping this will pan out. I got this thing fully disassembled now, and I need to familiarize myself a bit with the PCB. Obviously, this vehicle has two motors, one to control left and right, and then the motor in the back is going to send us forward and reverse. Up at the top there is basically the antenna coming into the PCB. It's a copper plate in which the antenna wire is soldered to. There goes the front motor. And I need to make sure that I know which is the typically positive lead heading to the motor and which one is the negative lead. Because obviously as you bias down one lead or the other, you're going to turn left or right. I also need to check the vehicle to see if it will operate on a lower DC voltage. The toy itself uses 3 AA batteries, which comes out to 4.5 volts. However, the Playtech toy uses 2 AAAs, which is 3 volts. So I'm going to take my benchtop power supply and I put it to my negative lead and my positive lead and turn it on and just check a few things to make sure that one, the DC voltage is showing up on the board as it should, and then 2, to ensure that this board can operate at a lower voltage. And as you can see, we are getting what we should get up on the board. I'm also testing out which wires will allow me to get the DC voltage into the PCB once the switch is on or off. I need to make sure that when I transplant this IC out of the vehicle and over into the toy dog that it would operate as such, or in the same way. And yeah, everything seems to be checking out just fine. It's also important that I at least write down on a piece of paper what is printed on the board for the leads I'll need. And essentially, this printed circuit board has everything labeled perfectly fine. MF for motor forward, MR for motor reverse, that's the back motors. It also has a ML and a MR for motor left and right, that's the front motor. But including VCCN and everything else. So if I get this recorded down on paper, at least I know exactly how to hook everything up once I transplant it over into the other toy. And essentially this is really all that's needed. I don't need to diagnose anything specifically on this IC, but I'm going to do that anyways, to be honest, after I write down everything that I need. So I've got it up underneath the microscope now. I'm just trying to work through a little bit of reverse engineering on this. I need to get my camera in focus there, but you can start to see essentially what is that chip? The MX1515. Yeah, MX1515H or W. We'll bring that into focus here in a second. But that's going to be the brush DC motor driver IC. And I'm just deciding to try to map out the entire pin out of it. I can probably throw the pin out up here on the screen in a little bit. But just as well as some other things on the board as I attempt to reverse engineer it. So yeah, let's get through reverse engineering of this, and I can show you what everything is once I'm done with that. And reverse engineering is complete. Well, let's go over a little bit. Up at the top is the model number that was on the printed circuit board. Right here is the SM6135W IC and then the MX1515H. Now up in the right hand corner here is the antenna end, but I left a lot of components off of the paper, essentially because you can find a data sheet for it to be able to know essentially what's going on there. But you do have a little bit of pre-tuning right here, basically to the oscillator of the SM6135W. What is that? My 5-function remote control car regulator chip, or RF receive IC. You know that there's a bit of pre-tuning before it. Basically, you have a ferrite slug sandwiched in between some coils. But it's going to try to match your input frequency up with the oscillator frequency, so the device can communicate. So if you needed to change, say, a different remote control that was slightly off, you could probably do that. Now, I'm going to throw the pin out for that IC up on the screen here you see in that left hand corner, and just try to orient myself with how it's positioned on the printed circuit board and how I have it written on paper as I mapped out everything for this reverse engineering, and try to go through a little bit of what's occurring here. Essentially, you know, on the controller you're hitting a button, and that's going to need to translate to something that the SM6135W must then translate into another function inside of the device. Alright, so pin 1 we have VO2, pin 2 is ground. Then up here on to pin 3 is an SI input. And then 4 and 5 is going to be our oscillator. Let's see, pin 6 is indicated as right, pin 7 is left, pin 8 and pin 9 are no connect, pin 10 is forward, pin 10 is backwards, pin 11 is forward. And we have a turbo on pin 12, which is not used on this device, but you might see on other vehicles. Pin 13 is our VDD in, pin 14 VI1, pin 15 VO1, and pin 12 VI2. This car also operates off of 2.4 volts, 9 volt or 12 volts, or I should say the PCB that we have here, but that's also dependent upon the components that we have in circuit as well as to which voltage is appropriate for use. I can imagine you'll have to change out some of our components here. Now, one thing I do want to note is that over here on the right hand side, I didn't write out everything for the antenna, but on the other side of the board is a metal slug inside of inductors. Basically offers a little bit of pre-selection to match up with the frequency of your oscillator for controlling things. And then you can see where everything is located on the board as well. That is our MX1515H, which is the brush DC motor drive. So essentially anything that it comes in over RF is going to be translated by the SM6135 over to the MX1515H for actually driving the motor, whether that is a forward input, a reverse input, or etc. And over here on pins, what was it? 10 and 11, that was our forward input and backwards input. And I'll probably need to mark that on my paper as well. Now let's see, pins 10 and 11 of SM6135 will send a forward or a backup voltage to pins 2 and 3 of MX1515 for controlling forward and reverse motor. More on the pins for that motor in a second. And pin 6 and 7 of SM6135 provides voltage for either left or right going to pin 6 and 7 of MX1515 for biasing the motor, controlling left and right. And now our motor pins. Let's see, pin 9 feeds to one side of our left and right motor. 10 and 11 are going to be some type of a ground. You have A ground and P ground. Let's see, pin 12 is going to be the other side of the motor for left and right. Again, we're not going to be using those pins. We will, however, be using pin 13, 14, 15 are not connect, and pin 16. That will provide DC voltage to our forward and backwards motor, and pin 16 also drives the LEDs on out of the PCB as well, so we'll make good use of them. From this point onward, I'm just going to start working on disassembly and moving that PCB out from this toy. Now I'll save things like the motor, some of the cogs and gears, because you know those are hard things to come by that can be used for other items as well. But you know, essentially I just want to take and rehouse everything into the other toy, and that's what I'm going to do. So let's listen to some music from here until I can test out the device once I have some things moved over. Got this hooked up, and yeah, looks like it's going to work just fine. I have to find a use for those LEDs on this PCB. Maybe we can incorporate them somehow into the Playtech Puppy as well. From here, it's just a simple mocking things up and put it back together. Feed the LEDs out through the bottom of the housing. Nothing really much to this, just need to determine that everything can fit, and if not, we'll definitely need to address that. And yeah, definitely not fitting the inductor sitting on the top of that 220 microfarad capacitor is hitting the top of the shell. And I also put the PCB just a little bit too forward, and so the posts are not fitting on as they should. But we can modify the shell a bit here and get all that figured out, no issue. Okay, let's try this thing out. That's reverse. Kind of like having those lights at the backside there. It's almost like it's got rocket boosters on it. Unfortunately, my oldest kid is kind of sick, so he's already down for bed while the youngest are getting ready, so I have to show it to him in the morning. But anyways, cool. I like it. Well, I'm not really sure what to make of this one. I don't know if you would call it a fix-it video or not. We actually just revisited this previous toy and then cannibalized parts out of another toy to give this one the function back that it originally had, and also went over a bit of the circuit diagram. But I don't know, you tell me what you think in the description, and let me know if you want to see me cannibalize anything else in the future to make other things work, so I don't throw things away. You know, components are, especially circuit boards and ICs and gears and motors, are pretty common to come by in kids' toys, and probably worthwhile to at least holding on to those components in case something breaks so you can make something else work. But anyways, I appreciate the fact that you watched. You know, if you enjoyed this video, then give it a thumbs up. Consider subscribing to this channel, and you know, as I mentioned previously, I can do repairs. You can see my business information and the link in the description. Takes you to my Google site. Or if you just want to donate, you can do that as well. PayPal's in the description. But yeah, I'm pretty happy with this. I'm pretty sure in the morning my son is going to be extremely happy as well. Anyways, take care. Goodbye.
Bart?